In this video, we are going to talk about statistics. So in this first question, it says, discuss the statement and tell what possible misuse of interpretation may exist. So at a certain middle school, half the students are below average in English. Therefore, the school should receive more federal aid to raise student scores. Now, if you think about the word average, the average refers to the middle value of a set of data. So if that's the middle value, then technically half of the students are below that number and half the students are above. And so when we're thinking about that statement, to say that the school should receive more federal aid, that's invalid because that's just what an average means. Now, it's invalid because if you're looking at the students in the population, they are expected to be, half of them are expected to be below average, half of them are expected to be above. So the school itself is not below average. So the best answer here would just be to say that it is invalid. The school is not below average. All right, in the second statement, we have 40 students that said they would recommend a certain Professor Greenberg to a friend. 30 students said they would recommend Professor Lowenthal to a friend. Therefore, Greenberg is the better teacher. Now, several things to think of here. First of all, we don't know how many students were surveyed. So yeah, maybe 40 students did recommend Greenberg, but maybe that was only out of 400. Whereas maybe we only surveyed 50 of the other students in the other professor's class and 30 of the 50. So you've got to know how many were actually surveyed. You can't just say 40 versus 30. Lots of other things too. You know, what makes a professor preferred over another, you never know. So this statement would not be valid. And when we're talking about why it's not valid, we don't know how many of each professor's students were actually surveyed. So it doesn't necessarily determine the quality of someone's teaching. So D would be our correct answer here. Okay, we are given a table in this third question, and we're asked to choose the bar graph that makes the increase appear to be smaller than it actually is. And we're looking at the median age of the men. So we're looking at this data within the graph. And so first, you want to look at the difference between the vertical axes on each graph. And so notice my values go from 25.9 all the way up to 27.8. And when I'm looking at this particular graph, it's more spread out there. And so then when I'm looking at the actual graphing, so the first year we start at 25.9. The second year it goes up to 26.3. So notice I've got a problem here because if this supposedly represents 25.9, which it doesn't because that's almost at 29, then the next year definitely is not 26.3. So that is a problem with that particular graph. The rest of them, they show an increase, and then it goes up again to 26.7, and then we go up again to 27.3. And so if I'm looking at this particular graph on that year, it did not go up again. So that is actually out. And so the other thing that I notice is with the 25.9, if this starts at 25.8 and this is 27.9, this is not accurately shown there. So the one that makes the growth appear to be smaller would be D, and it's because of this vertical axis being so, going from 0 to 50. All right, in the next question, we're given a table of numbers, and we're asked to construct a frequency distribution. So first, to get my different classes, if you'll notice, we're going from 85 to 94.9, so this next class would have to start at 95. and then we would actually go up to 104.9. And then the next class would have to start at 105, and it would go up to 114.9. And then we'd have 115, and then that would go up to 124.9. And then notice that continues with the pattern, 125 to 134.9. So then on the next one, we would be at 135, and we would be going up to 144.9, and then finally 145, and we would go up to 154.9. And then it's just a matter of counting how many are in each particular interval. And so between 85 and less than 95, if I go through and count, here would be one value, here would be two values, here would be a third, here would be a fourth, 5, 6, and 7 different values. So all of those are 85 or higher, but they are less than 94.9. So 3, 6, there would be 7 values. And then you would just continue on with the rest of those classes. Okay, so with the next one, you're constructing what's called a stem and leaf plot. And so what happens on a stem and leaf plots is you put your tens digit on the left, and we're going to use ascending order. So we have 0 tens, 1 10, 2 tens, 3 tens, and 4. And then you just go through the list and you put the units digit on the right. So if I have the number 13, I'm going to find the 1 and then put a 3 here to represent 13. For the number 14, I find the 1 again, and I just put a 4 out here. So the leaves on the right-hand side, you're not separating them with commas, you're just listing them out. And of course, you have a vertical line that's separating your stems from your leaves. For the number 5, you would use a stem of 0, and you would put a 5 out next to it. For the number 9, you'd come back and stem of 0 and a leaf of 9. And then you would just continue on doing that for the rest of the table. Okay, with the next problem, when we're asked for mean, that's just your numerical average. So you're going to first add up all of those numbers, which if you want, you can do on a calculator, and then just be sure you show me that sum. So I'm adding them all up. And I get a total sum of 144, and then you divide by how many there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different values. So 144 divided by 9 would give me an average of 16. Now for median, you have to first make sure they are in order, which those are. If they're not, you have to put them in order. And then you find the middle value. So what I always do is I cross one off the bottom end, cross one off the top. Bottom, top, bottom, top, bottom, top. Now, sometimes there will only be one middle value. And in this case, we've got one middle value, so the median is 16. If you end up with 2 middle values, then you take the average of those 2. Mode refers to which one occurs the most. So if I look at my list of values, notice that I have 12 occurring twice, 16 occurs 3 times. So my mode in this case would be 16. And then mid-range, if you think of it, that's like saying the middle of the range. This is where you're going to add your low value plus your high and divide by 2. So it's like you're taking an average. So my low value is 12. My high value is 28. And I'll divide that by 2. So 12 plus 28 would be 40. And 40 divided by 2 would give me a mid-range of 20. So that's like the middle of the range. And then finally, on the last one, your range just refers to the difference between your highest and your lowest. So my highest value here is 14. My lowest value is 6. So my range would be 8. And for standard deviation, this is a kind of a complicated calculation. It can be done on a calculator if you know how to input the data. But first of all, you've got to know what your average is. So I'm going to go ahead and average those values real quick. So add them all up. My sum is 50 divided by 1, 2, 3, 4, 5 values. So my average is 10. Now, what you're going to do in each case is you're going to take each number minus the average. Okay, so 8 minus 10 would be negative 2. 6 minus 10 would be negative 4. 11 minus 10 is 1. And 14 minus 10 is 4. And then you're going to square them. So 1 squared is 1. A negative 2 squared is 4. A negative 4 squared is 16. 1 squared is 1, and 4 squared is 16. And then you're going to add all of those up. So 1 plus 4 would be 5, plus 16 is 21, 22, and then this would give me 38. So you're going to add all of those up, divide by how many there are, and take the square root of that number. And that's what actually gives you the standard deviation. So 38 divided by 5, and then I'm going to take the square root of that number. So my standard deviation is 2.76.